We'll focus on some of the practical questions in inorganic chemistry, primarily to do with group 2, group 7, and period 3, and some of the practical questions on transition metals. So let's just go over a few inorganic tests which are compulsory, or we must know in that sense. So, test for carbonate ions. So the test for carbonate ions is add acid like hydrochloric acid. So carbonate ion, add acid like hydrochloric acid, and it will produce fizzing because carbon dioxide is given off. Carbon dioxide is a acidic gas and can react with sodium hydroxide or potassium hydroxide in the lab also. The test for sulfate ions is you add a solution of barium chloride, barium nitrate, and you will get a white precipitate of barium sulfate. Alternatively, the test for barium ions, so if you want to do a group 2 test for barium ions, you would add a solution of sulfate, magnesium sulfate, copper sulfate, sulfuric acid, and there you will also get a white precipitate. The test for magnesium ions, you add a few drops of sodium hydroxide solution and you will get a white precipitate. But you also get a white precipitate with aluminium ions. So how do we differentiate between these two white precipitates? And that's where you add excess sodium hydroxide, and aluminium hydroxide will dissolve to give a colorless solution. Other tests you need to know, ammonium ions for example. So the test for ammonium ions is you add some sodium hydroxide, and I'm doing ionic equations on purpose because most of the questions will ask you for ionic equations. You warm gently in a warm water bath, and then you will test the gas given off with a red damp litmus paper, and it will turn blue because ammonia is given off. Other important tests: halide ions. The test for that is acidified silver nitrate, acidified with silver nitrate and silver nitrate. The reason we use nitric acid and not sulfuric acid or hydrochloric acid for acidifying silver nitrate is because silver nitrate will dissolve or react with any excess carbonate ions. Hydrochloric acid can increase the percentage of chloride ions in solution, so your precipitate may look white, and sulfuric acid could also give some sulfate precipitates which can be present in salts, because salts are not always pure, there are some impurities. Now you get a white precipitate of silver chloride with chloride ions. This is the equation you need to know for silver precipitate. The silver chloride will dissolve in dilute ammonia to give you a colorless solution. The silver iodide will not dissolve in any forms of ammonia. And silver bromide will dissolve in concentrated ammonia. And when silver chloride or silver bromide dissolves in ammonia, you will get the Tollens reagent produced, which is a complex silver diamine complex. And the other important tests you need to know, and they're not really lab tests, we will not necessarily use concentrated sulfuric acid to test for halides because of the corrosive nature of products produced. However, we can use concentrated sulfuric acid to show the reducing ability of halides. That's where concentrated sulfuric acid comes in. When you've got sodium chloride or sodium fluoride, they do not reduce sulfuric acid at all. So it becomes an acid-base type of reaction, and your observations are steamy, misty fumes of HCl or HF. So they're basically acidic corrosive fumes are given off, and those fumes are white. However, when sodium bromide reacts with sulfuric acid, you'll get bromine produced as well as HBr, but the main observation is bromine, which is a orange brown vapor, and sulfur dioxide produced. So the sulfuric acid, the sulfur in sulfuric acid is reduced from +6 to +4, and the Br minus is oxidized from -1 to 0. In the case of iodide, iodide is a powerful reducing agent. So sodium iodide with sulfuric acid can reduce sulfuric acid to sulfur dioxide, to sulfur and H2S. Sulfur is a yellow solid, and H2S has a really bad smell, like bad egg smell. So that's just a quick overview of some of the inorganic tests you need to be aware of. So I have some questions which we can very quickly look at in order to apply some of the understanding we have. So the main practical here is practical 4 and practical 11, but I'm not mainly covering transition metals here. Main objective here is for you to understand the precipitation reactions, the inorganic tests. So we look at test 1. When sodium hydroxide is added to something, you get a white precipitate. You can get aluminium hydroxide, you can get calcium hydroxide, and you can get magnesium hydroxide. But because the question says group 2, it won't be aluminium hydroxide. And the reason we will say it's magnesium hydroxide, because as you know, group 2, the group 2 solubility of hydroxides increases down the group, which means magnesium hydroxide is the most insoluble. So that would be magnesium, and the equation would be 2 hydroxide gives you MgOH2, and this is a question from, I believe, 2025 paper last year. So, and when you get a cream precipitate with silver nitrate and nitric acid, that will be AgBr, and your ionic equation will be Ag plus Br minus. So it's important that we learn, and this is something that needs to be learned. Okay, and the reason why we add nitric acid here, why do we add nitric acid? And that, I said earlier, is to remove any carbonate ions or any other ions that will give you a precipitate here. So that's the reason why. Okay, barium sulfate, as you know, is insoluble. It absorbs or scatters X-rays as an explanation. So let's look at the next question. So next question is about group 7 chemistry. Give an equation for the reaction between solid sodium bromide with concentrated sulfuric acid to form bromine. My advice here is the best way to learn this equation, and this would be my advice, would be to learn it like this. Sulfuric acid, and this we can practice how to write half equation, forms sulfur dioxide. So the rule is, when you have what we call a complex ions or substances here, the first thing is let's balance oxygens with water. So I've got 4 oxygens on the left in sulfate ion. I've got SO2 has 2. So let's put 2 waters on the right. I already have 2 hydrogens, so to balance H2 hydrogens in water I need H plus, so I need 2 of those, and to balance charges I need 2 electrons because I have no charge on the right. Then bromide becomes bromine, and balance the equations with electrons on the right. So the 2 half equations will have electrons. One will have electrons on the left and the other one will have electrons on the right. Add them up, H2SO4 plus 2H plus 2Br minus. You can write this as HBr if you wish. SO2, bromine and 2 waters, and that will actually work, and that is acceptable and that is correct. You could do it another way where you get sodium sulfate, sulfur dioxide, bromine as well, but this one would work. Now what are your observations? Brown fumes. Okay, also there is another observation here, but they don't always accept that because sulfur dioxide is like a choking gas, but bromine giving you brown vapor will be clear. Then a solution is thought to contain chloride ions and iodide ions. So give a reason for each of the reagent used. We've already looked at nitric acid. We've said nitric acid removes ions which could give us precipitates like carbonates and sulfates. Silver nitrate is added to give you a precipitate of silver chloride and silver bromide, so they will give you a white and cream precipitate respectively. A pale yellow precipitate forms. That could be a mixture of 2 precipitates. Excess or iodide, actually I just realized iodide, so it won't be bromide. So if it's a pale yellow precipitate, that means there's a mixture of silver chloride which is white and silver iodide which is yellow. So we've got mixture here. Excess ammonia is added which dissolves the white precipitate of silver iodide, so it dissolves it, and some of the dissolves in and darker remains. Give the ionic equations. Well, we've already done these now. Ag plus I minus and Ag plus Cl minus, and there's another very important equation you have to give. Some of the precipitate dissolves, that means AgCl dissolves in ammonia, which I've already mentioned. They haven't asked for state symbols here, so you don't have to give state symbols if they haven't asked for it, and that gives you the diamine, which is a Tollens reagent, and chloride ions. So you can see now the nature of the question. Now you will see some of the questions start to repeat themselves. So for example, this question 3 I think is from either from 2023 or 2024 paper. Sodium chloride reacts with sulfuric acid. So I've already done this above. It's a question of remembering this reaction. I normally write it like this. You can write it with Na2SO4. What's the role of sulfuric acid? It's a proton donor. You could say it acts as Bronsted-Lowry acid. Now, these are the equations you must remember. Fumes of sulfur dioxide are formed when sodium bromide reacts with concentrated sulfuric acid. I'm not going to repeat this because I've already done this equation here, there. So make sure you can write half equations where sulfuric acid also produces a sulfur and also produces H2S, and then balance it. So you got to be able to write these with bromide and iodide. These two will be written with iodide here. So those are the equations. Again, look at the repetition. We've had a question before. So the observations will be brown gas fumes produced, and the role here of sulfuric acid is it's an oxidizing agent, not a acid. It's not behaving as an acid. Okay, now let's look at the next question, and really lovely question. I really like this question because it's a good way to practice what's going on here. Solution Y contains two different ions. To a sample of Y, we add silver nitrate. Whenever you see silver nitrate, you know that's a halide test. Excess nitric acid, so that confirms halide test. Finally, excess ammonia, we're testing whether the halide dissolves or not. So we're looking at chloride, bromide, and iodide test, or AgCl, AgBr, AgI test. Cream precipitate, so D must be silver bromide. Okay, and it gives you, because you have an added nitric acid, so that means E could also be silver carbonate, because the carbonate ions have precipitated out. It's only when you add nitric acid that they will dissolve. Now, when the cream precipitate and bubbles of F, so bubbles of F, that means that F must be carbon dioxide, because we've established there's carbonate in there. And then the equation is AgBr plus 2NH3 forms, and now you can see the repetition here of the reaction that's happening. So another really nice question to practice here. Pause the video for your liking, and now let's look at question 4, because question 4 is just a comparison with silver chloride. Reacts with water to form a solution. Now this falls into transition metals. Whenever you have a transition metal or silver chloride salt, whenever it reacts with water, it will produce the hexa-aqua complex. Okay, 3Cl minus. How Z reacts as a Bronsted-Lowry acid? You can just do it like, probably better to do it like this. So the water, because water is acting as a base here, water will gain a proton here. So that's 2 plus, and it will become H3O plus. That's what it's acting as. Two observations when sodium carbonate. The two observations will be white precipitate and effervescence. White precipitate, effervescence, or bubblings. Right? Don't abbreviate like I'm doing. And the equation always, just remember it. You need 2 of the 3 plus ion. So you need 2 of the 3 plus ion and 3 carbonates. Good way to remember this is 3 times minus 2 is minus 6. 2 times plus 3 is plus 6, so the charges cancel out, because on the right hand side there are no charges. And now you've got OH3, H2O3 plus 3 waters and 3 carbon dioxides. Okay. Aqueous potassium hydroxide is added until in excess to solution Y. Describe 2 observations. Look, one, you will get a white precipitate, which I talked about on the top. Secondly, the white precipitate dissolves. Now, that's not the observation. The observation is to form a colorless solution. Remember, a colorless solution. The word clear is not an observation. Must be clear on that. So here I'll do the equation 3 plus. Now there are several forms of the equations here. You could do it with 1 OH minus, which I prefer, and that will give you Al. Sorry, here you've got to have, let me correct this because that's not correct. Because we are starting with the precipitate, I'm going to use hydroxide here. That will give me Al OH4 H2O2, okay, minus, and 3 waters. That's probably the better one. This is equation 2, by the way. This is equation 2, not equation 1. Equation 1 is where you get Al H2O6 3 plus and 3OH minus, and it will form this and form 3 waters. Okay, and lastly, let me see what's on here. Yeah, the last one here, the last question I want to look at is the one here, that the following tests were carried out to identify unknown green salt. Take a pencil, must be Fe2 plus, because iron 2 is green. Yes, so iron 2 is green. An aqueous solution Y gave a cream precipitate of compound A, so cream precipitate must be AgBr. Compound A gave a colorless solution reacted with ammonia solution. Okay, so that could be compound A, so that could be AgBr reacting with ammonia to give you AgNH3 2 plus solution. Aqueous, another solution, we gave a green precipitate with B, so that green when reacted with carbonate, that has to be iron carbonate, because when 2 plus ions react with sodium carbonate, you get a precipitate, either iron carbonate or copper carbonate. That would be the other possibility. The green precipitate was filtered, dried, reacted with sulfuric acid to give you a pale green solution containing compound C and colorless gas D. So the gas is probably carbon dioxide. And the identity, now you can see silver bromide as we identified from the top, iron carbonate as we identified on the top, and iron sulfate and sulfur dioxide, and that means that Y must be FeBr2. Okay, the other one we've done between the green precipitate and sulfuric acid. So if we're doing ionic equation, you got sulfuric acid reacts with carbonate, gives you water and carbon dioxide. And that is really some of the reactions that will come up. Learn magnesium reacting with steam. You will get a white precipitate, and you will see a bright white flame because gas is given off here. And when sodium is heated in oxygen, you will get sodium plus O2 will form Na2O, make that a 2, make that a half, and again sodium gives you a white precipitate, but it does burn with like a orange flame or whatever, but that's your main precipitate. And that is it really. That's a quick rundown into some of the inorganic practical questions for